So this is the triaxial setup. Okay, this setup having three components. One is the load frame. This is the control panel, and this is the data acquisition system. Okay, so data acquisition system is having one computer, and this is the interface only. So first we will go through the load frame. So this is the load frame. This is the digital load frame. Digitally you can control the speed of this load. So this is the displacement control load frame. Okay. So here we will apply the displacement from the bottom, and here you can see one load cell is there of 100 kilonewton capacity. With the help of this you can control the measure the load. So this is ultimately 50 kilonewton load frame. Okay. So here actually three things is there. One is the strain applied chamber, load cell, and LVDT. So LVDT is of 50 mm. Okay. So this is 10 kilonewton load cell, 50 kilonewton loading frame, and here you can control the speed of the frame. Okay. So digitally you can control the speed in mm per minute. Okay. And this is the on off. This is a very simple thing. Okay. And this is the universal chamber. Okay. Okay. So this is the base plate. In base plate, what is there? So there 4 valves are there. You can see here. Okay. So 3 are in this direction and 1 in this direction. Okay. So this plate, base plate is having one pedestal. This is called pedestal thing. You can change the pedestal. Depending on your sample size, you can change this pedestal. Okay. So right now it is attached 50 mm diameter pedestal. So with this pedestal you can prepare the 50 mm dia cylindrical sample. So if you want to prepare the sample of 100 mm, you can just change this pedestal, and then you can prepare the sample.
One minute.
So you can see here. So this valve is connected to this hole, and this is on the outside of this pedestal. So with the help of this valve, you can apply the confining pressure. Okay. So from outside of the sample, you can apply the confining pressure. So in this pedestal, you can see there is two holes are there. Okay. So this side hole will be connected to this nozzle, and this side hole will be connected to this thing. So with the help of this hole, you can measure the pore water pressure in the sample. So this is the pore water pressure transducer. The capacity is around 200 kPa. So this valve is attached to this one. So this will connect to the top cap. Top cap is there. So in between you can prepare the sample. From top cap you can ensure the drainage thing. From the drainage you can ensure the saturation. Okay. So that's it. So this is having two things, loading frame and the chamber. Coming to the control panel, pressure control panel. Okay, here 2 chambers are there. One is for the confining pressure control, another one is the back pressure control. Okay. In this thing, two lines is there. Okay. One is the water line, another is the air line. Okay. So how to apply the confining pressure and back pressure to the triaxial setup? So here you can see one tube is there, and inside the chamber one tube is there, that is the black side. Okay, that is the rubber tube. So in the rubber tube we will apply the air. So this is the air water thing. So with the air water interface we will apply the pressure to the chamber, either in the form of confining pressure or in the form of the back pressure. Okay. So this is the water line. So you can see there, this water line is connected to the confining pressure and back pressure. So this water line is going to the chamber, both respective chambers. Okay. So this is the air line. Okay. Through the air line, this is going to the tube. So you can see here, this is the air line, both the line is connected. You can regulate the pressure here. Okay, 2 regulator is there. from this two regulator you can control the pressure, and this regulator is connected to the tube. This is having one volume change device also. The capacity of volume change device is 100 cc actually. Okay. With the help here one valve is there. Either you can bypass the volume change, or you can choose for the volume change. So if you want to go for the volume change during the shearing, you have to rotate in this direction, and if you want to bypass, then you have to change the direction of the valve. Okay, and this is in the closed position, and this valve is in which direction you want to measure the volume change, either in the up direction or down direction. So right down it is in the down direction. So first what we have to do, we have to place this membrane to the pedestal of the sample, okay, through this hollow cylinder. Okay. So first I am attaching this membrane, rubber membrane, lattice membrane actually, to this hollow cylinder. First place the pour stone to the pedestal, then the filter paper, and then place the membrane. Then you have to place the O-ring to get fixed this membrane to the pedestal. How to place it? Here one groove was there. In that groove, on the from outside of the membrane, you have to place the O-ring. Okay. So now our membrane is attached to the base plate, and inside pour stone and filter paper is there on the bottom side. Now what we have to do? We have to attach the split mold here to prepare the sand sample. So this is the split mold. Okay. So what we will do? Attach this. Then we have to clamp it. So this is the clamper. Two clamper is there. So I have to attach one more to get rigidity. Now our split mold is fixed to the pedestal. Inside the membrane is there. Now what we have to do? We have to make it like this. Prepare the sample. So to prepare the sample, what we have to do? So this is the dry mass of the sand, which is equivalent to the to compact the sand at the required density in this volume. Okay. So first, what you have to do? You have to apply the suction so that this membrane should be attached to the inner side of the mold. So for that, the two valve is there. I will apply the suction with the help of these two valves. So I am attaching the suction pump to this thing. So suction, with the help of suction assembly, we will apply the 2 kPa suction pressure to the membrane, so that this membrane will attach to the inner side of the assembly, a split mold. So after applying the vacuum to this membrane, what we will do, we will start compacting the sample in this split mold. Okay. So with the help of this funnel, we will place the sand to the inside of this mold. Okay. So we will apply in the three layer. So first I have placed the 1/3 of the sand in this split mold. Then with the help of this compaction rammer, I will apply some energy to this to achieve the 70% density. So this is the heat and trial method. So number of blow can vary to person. Place the second, third one. So I apply. For me, it is around 30 blow to per layer. So I have placed the whole amount of the sand on the required height of the sample. So this is around 70% relative density. So on the top of the sample, first place the filter paper. Then place the porous stone. Then place the head. As you can see, in head also one groove is there. Okay. So what I have to do first, we will place this membrane to the outside of this assembly. Now this is placed. So again we have to place the O-ring on this groove. So how will I place? Again I have to place this O-ring with the help of this hollow cylinder chamfer. Now this membrane is attached to the top cap. Now we will do the disassembly. First we will remove the vacuum pressure. Before removing the split mold, what we have to do, we have to apply some suction to the sample to get the rigidity. So with the help of this, so as this valve is attached to the back pressure, we will apply some suction, say 20 kg. First attach this one and close this valve. Now apply the suction. Then slowly remove the split mold. So now your sample is ready with the 20 kPa suction vacuum pressure. Now what we have to do, we have to place the outside chamber to this base plate to apply the confining pressure. So now we have to place this outside chamber. Be very careful while placing this. Now we have to clamp it properly such that there should not be any gap in between. Okay, so this water line is attached to the both confining pressure and back pressure thing. So what we will do now, so here you can see there is two outlets. This assembly is coming to this control thing. Here this is the inlet which is attached to the water assembly line. Here two outlet is there. One outlet is going to the chamber to control the pressure, and this will connect to the sail. So this is the outlet thing. So this outlet valve will be attached to the sail. Okay. So here all these three valves is interconnected in this panel. So now what we will do, we will attach this outlet to the confined pressure valve. So this is our confined pressure valve here. So attach it. So now this water line is connected. So, so look at here. This confining pressure sail outlet is connected to the water inlet, and this water line assembly is connected to one of the water tanks. This is the water tank. Water is placed at certain height to so if you want to fill the chamber, so obviously there should be some potential difference between chamber and water tank. Okay? So that's why this water tank is at a higher elevation, so that due to the potential difference, water will go to the chamber. So here one valve is there. I will open this valve. So water will come out from this water tank from the bottom. One valve is there, water valve is there. In top also it is open. So two openings are there. So that is either to apply the vacuum in this thing, or the water will come out. Air should go in that tank. So two openings are there. So look at here. One opening is there. It is open now. So with the help of this thing, the air will go. And with the help of this water outlet, water will come out. So now I have opened this. So from that water tank, water is coming to this. So this is the water assembly line. So now I am opening this valve. Okay. So I have opened this valve. This will come to here. Now this will go to this thing. So again I have to open this line. So horizontal one means it is closed. If it is in this direction, means this is open. So now this is open. Now water came to this thing. Now where I have to place the water? To the chamber. So this is connected to the chamber. So no. So to fill the chamber, I have to open this valve. One opening it. Now coming to this. So now water has reached to this, up to this point. So now again I have to open this outlet. This is open now. Now water will start coming to this sail. So look at here. Okay. So in the top of this, two air vents are there. Okay. So first we have to open both the air vent. Open the air vent, water will start coming. So look at it. So while water is filling to the chamber, what we will do? We will place this plunger to the top of the sample. So here you can see this plunger is not attached to the top of the sample. So slowly place this. Okay. And then with the help of this, you can make it a static. So this will not allow to get disturb the sample. So it will take at least 20 to 30 minutes to fill the chamber. So till that you can wait. After the filling, you have to set it centrally to the load frame. then you should remove the suction first. So let the LVT be here. Now the sail is ready. Now what we have to do, we have to apply the required confining pressure through this assembly. Okay. So for that we have to switch on the pneumatic pump. With the help of the pneumatic pump, we will apply the pressure to the air line, and we can regulate the pressure. So first switch on the pneumatic pump. So this is the pneumatic assembly, okay, or you can say pneumatic pump. This is the air dryer thing. So those air should be moisture free. So first switch on the air dryer. So now our pneumatic pump is on. So through that pneumatic pump, air is coming to this air line. Okay. So as this is the UU test, unconsolidated undrained test, what we have to do, we have to apply only the confining pressure. There is no need of this back pressure. Okay. If you will do the CU or CD test, then the back pressure will come in the picture, and also the volume change device will come in the picture. Okay. So in the UU test, only confining pressure will come in picture, and the back pressure and volume change, there is no need of DQ. Okay. So now we will switch on the air line. So this is the initial part. So make sure all the lines are, so this is the lines, okay. So the air line is going to the confining pressure through here, okay. So make sure this is closed and this back pressure thing is closed. So only what we have to do, we have to open this line which is controlling the confining pressure thing. So switch on this. So now air line is open. So initially we will apply the 50 kPa. 50 kPa means 0.5 kg per centimeter square. Okay, so you can see this is the zero thing. Outer circle is like, look at this. So outer reading is in kg per centimeter square. Inner reading is in lb per inch square. So we have to apply the 50 kPa pressure. 50 kPa is 0.5 kg per centimeter square. So through this valve you can control the pressure. Through this you can control the confining pressure, and through this you can control the back pressure. So right now we are using only confining pressure thing. So now first control the thing. So till date you can switch off this valve because this is going to the cell pressure. Okay. So first control the pressure. So this is around 0.5 kg per centimeter. So now switch on the outer valve. So this will go to the cell pressure now. So now before you are going to start the test, what you have to do, you have to you have to put the initial data in this thing. So this is the actually data acquisition system. So this is you can see this thing in this monitor also. So with the help of VNC viewer, you have to connect this. So this whole screen is now visible here. Okay. So what we have to do, we have to give the initial data. What is the sample ID? Sample ID is sand, medium sand. Okay. Now we have to input like sample diameter. What is the diameter? It is first you have to clear it. This is 50 mm. Now sample height. What is your height of sample? It is 100 mm. Okay. Now path is already defined. Now you have to enter the thing. So this is the sand with 50 kPa pressure. Okay. Now we will go to the loading frame now, and we will set the Now coming to the loading frame, so this is the touch screen here. So here, what is thing here? You can set the speed of this frame, and you can choose the direction up and downward. So first we will choose the speed here. Okay. So as the sample height is around 100 mm, and it should be around pressure should be around displacement rate should be around 0.5 to 2%. So I will choose like 1.25. So that will come in between. So 1.25 mm per minute. So a speed is 1.25 mm per minute. Now what we have to do? You can start it. Before I start, you have to give the direction up or down. Obviously this assembly will go to up. So we will. So first what we have to do, we have to make ensure that our this plunger is attached to the load cell. So first we will go with the slow rate, or specified rate. And we will see if load cell reading will change, then we should have stopped that, and the reading after that we should have start taking the reading. So now you can see here, this valve is like loosely here. If you will touch through the load cell, this will be in tight position, and also the load cell reading will start changing. So right now what is happening, this base thing is coming up at the rate of 1.25 mm per minute. Still it is in loose position, and load reading is not changing. Okay, it start changing, so you should stop it. Okay. So now it is the plunger and load cell is in proper contact and it is concentric also. So what you can do, you can open this. Okay. Apply the confining pressure here. So this is the confining pressure valve. So before to start the reading, what we have to do, you have to tear all the initial reading. Okay. So tear this reading. So this one is pore pressure. So and this is the volume change reading. So there is no need to tear these two values as we are not recording these two values or these two are not connected here right now. Here you can see the displacement rate is changing and corresponding load is getting captured through the load cell. Okay. So here 4 tabs are there. Okay. So in this tab, what will be there? Load displacement curve you can see. This is the time graph. Okay. In time graph you can see either you can see the load versus time or displacement versus time. As there are two more variables are there, pore pressure and volume change. Okay. And this is the data table. So here you can see the data is getting recorded after every 10 seconds. Okay. So this is the load column and this is the displacement column, and these two more columns are there for pore pressure and volume change. So pore pressure and volume change reading will not change, only these two columns will change with the time. Okay. Or you can see the load displacement curve also. I think still it is not in proper contact with the load, that's why load is not changing. Now you can see it will start getting. So you have to do the initial correction. Okay, so means your test is started from this thing. So this much time took to get proper contact and all that. So this is your initial reading. Okay. So when you will plot this reading in the Excel, you have to remove these readings and then you have to show the stress strain curve or load displacement curve or whatever thing you want to plot. Okay. Now thing is when will you stop the test? So as I think I have already discussed previously, so this is the displacement control test or a strain control test. Okay. So this is not a load control test. So in this thing what we are doing, we are applying displacement to the sample at a certain rate, at a constant rate. That rate is already we have set like 1.25 mm per minute. Okay. And then we are capturing the load, okay, through the load cell. So here what we will get, we can so what is the advantage of a strain control or displacement control test? You can capture the post peak response also. Okay. So after if you will get the peak also, you can measure the load at a certain displacement and all that. This is the advantage of a strain control test or displacement control test over the load control test. Okay, in the load control test, what will happen? You have to stop the test after peak. So after peak, you can't, you will not get any response. So from this curve, it is clear that slowly it is reaching to the peak because the slope of this curve is getting flattened. When will you stop the test? Either there should be a sudden failure, then you have to stop the test, or after the 20% strain. So the sample height is around 100 mm. Though what will be the 20% strain? That will be around 20 mm, right? So now you have capture of around. So as your load is started from 3 mm, you have to consider like 3. So it went up to I think around 4 mm. So either you can proceed up to 20 mm, or if this curve will pass the peak at a very large amount, then you can stop the test. So slope of the curve is almost flattened. Okay, you can see. I think the peak of the curve is very near, and after some time it will start decreasing or it will become constant. As you can see here, okay, so as the test is proceeding, you can see your sample is start bulging. Okay, you can see at the mid height, almost at the mid height of the sample is bulging. So now what is happening? You can see here the peak value is coming down. So the peak value has reached somewhere at this displacement. So now the load value is coming down. This line is showing the peak value. So the load is now decreasing. So sample is going to the fail now. So you can see the shape of the sample also. Now look at the shape of the sample. Look at the shape of the sample also. There is one failure line on this direction. So look at here. So you can say the lower portion and upper portion is slipping on this failure plane. Okay, so your sample is almost failed. So either you can stop the test or you can see the constant volume portion. As you can see, the sample has already failed before reaching the 20% axial strain. Now we have to stop the test. So from here, what you have to do? Stop the test, and you can start the unloading also. So unloading happening at a higher rate. That rate is around I think 30 mm per minute. Now what we have to do? We have to close the confining pressure valve. and then you have to release the pressure. Okay, as you can see here, now the pressure is around 0.5. I am releasing the pressure. Okay. So after releasing the pressure, close this valve. Okay. Then close the air water interface valve. Okay. And you can close the air line now. Now what we will do? Close the air line and start the water line, because what we have to do, we have to remove the chamber water to that water tank. Okay, so switch on this line. So this is open, this will go to this. Now this should go to the water tank. Open this line and all the other lines should be closed. This is closed, this is closed, and this is closed. Open this. Open this also. So what you have to do? Now we have to apply the suction. Now we have to apply the suction to this water tank, so that it will suck the water from the triaxial cell to this tank. How to do? As I have already told you, there is two air line is there in up. So I will close one line, and I will apply we will apply the suction to the top. So apply the vacuum in the water reservoir, then only water will start coming out. So after the test, you can see the post. You can do the post analysis through one of the software is there, triaxial reporting. Okay. Before the triaxial reporting, what you have to do? You have to import the data. The file name was the sand 50 kp. I am exporting these two to here. So I exported the data on the desktop. Now what you have to do? Triaxial reporting system. Go there, new compilation. You have to give one file name. This is the medium sand. Geolab. Here what is there? First you have to choose the type of test. That is the UU test. You can say the project ID. Geolab 1. Project site you can give the remark also. You have to put here sample ID, that is medium sand 1. Length was 100, sorry 10 centimeter. Diameter 5 centimeter. Weight was around 320 gram. Water content was 0. Dry sand, specificity 2.61. Sigma 3, what was the sigma 3? It was 50 kPa, means 0.5 kg per centimeter square. Okay. Now what you have to do? Attach the file. From here now we have what you have to do, you have to select the levitic stress versus axial stress. So this is the curve. So this, actually we have taken this data, we have stopped the test at here only. This is the mode circle. So there will be no PQ plot because to conduct the PQ plot, you should have a multiple data. So this is your mode circle. Okay. So right now what is happen? If your intercept, you can change the slope also. Manually you can say. So as it is a sand, you can make the intercept 0 and you can get the slope. So manually I am drawing the tangent to this circle. So you can see the tangent is this one. So the slope is 54.4 degree. Intercept is 0. So this is the intercept, this is the slope. The slope is 54.4. So on the basis of one more circle, this is the 5L, because we have drawn the tangent to this more circle. Now you can export this data also. To get the real C phi, what we have to do, we have to again perform the test for the different confining pressure. So this is for initial one 50 kPa, next one should be around 100 kPa. So look at here, x-axis, this is 0.5 kg per centimeter square. Next reading will start at 1 according to IS code. Then next third reading should start at the 1.5 kg per centimeter square confining pressure or 150 kPa confining pressure. Okay. So on the basis of only one more circle, you can conclude that C is 0, as this is the dry sand. C could be 0. Okay. Now what you can do, you can export the test data. So this is your test report. Test type UV test. Project ID is GeoLab1. This is your stress strain curve. X axis, y axis is denoted, and this is your mode circle.